The second part, we come to the properties of determinants, which is a very hard part for you, who is the first time to touch determinant. But basically, the property of determinants consists of two very useful items, which we can simplify the determinants. The first one will be we can be doing row or we call column operations. So then in the coming examples, we are going to demonstrate the ideas. So second one would be we can take out the common factor. So it is another very good tool for us if we are going to factorize our determinant. So let's take a look on the coming very standard example in the past paper. So now we are going to factorize the following expressions. So the question is called you are going to factorize. The expression will be a very big one called 1 plus a squared, 1 plus b squared, and 1 plus c and c squared. So first of all, in our observation, we find that this 1 can be cancelled by the next one. So first, so now I try to use the first operation calling C2, column 2, minus column 1, and then put it into column 2. So what does that mean? That means column 1 unchanged, column 3 unchanged, and then column 2 you need to minus column 1. So that means a plus 1 is minus 1, give you an a, 1 plus b minus 1 gives you a b, 1 plus c minus 1 gives you a c. And so we finish the first part of column operation. Afterward, we go ahead to simplify the numbers. We find that there are so many ones here. So I aim to cancel the 1 and 1 in the second row and the third row. So as a result, the second operations I'm doing will be row 2, I want to minus row 1. So put it back with row 2. Row 3 minus row 1 as well. And then so next I put it back to row 3 in this calculation. So for my habit, because there are two different operations, I will label them 1 and 2 over there, also for clearer presentation. So what does that mean in the operations here? So you will see as follow. Row 1 is being unchanged, and then next, so red one first, how about 1 minus 1, you have 0, b minus a, you have b minus a, b squared minus a squared, you have b squared minus a squared. This is the first part. Green, for the second operation, you have row 3 minus row 1, 0. Row 3 minus row 1, c minus a. Row 3 minus row 1, you have c squared minus a squared. Then we complete the second row operation. So now followed by, you will see, if you read it clearly, b minus a so can be found here, and even in 0. Similarly, c minus a can be found here, as even 0. So the next job will be we are going to take out the common factor in the second row, which is b minus a, while it is in the third row you have c minus a. So now we successfully take out two common factors. So these two common factors are taken from row 2 and row 3. So then the only thing left behind will be 0, you have 1, and b plus a. Similarly, you have 0, 1, and c plus a. So in this operation, you will see that the first row, there is no change. So we copy 1a squared over there. So after that, you continue to break down, or maybe call factorize the determinants. So my habit is, if you have can cancel some numbers quite easily, so let's go ahead. So for example, this one can be cancelled by row operation. So that's why I do one more job, and then so which is called row 3 minus row 2, and then move to row 3. So whereas now you will have the following: b minus a and c minus a, so it's taken out as common factor already, and 1a squared, no change for the row 1, and then row 2, 0, 1, b plus a, no change, and finally the only thing changed will be 0 minus 0, you have 0, 1 minus 1, you have 0, c plus a minus b plus a, you have c minus b. So let's pause for a while to see whether you can follow. If okay, finally now we are going to expand it with the rules called positive and negative in the expansion of determinants. So as a result, besides b minus a, c minus a, which is factorized already, and now we are going to expand it. So we have 1, 1, c minus b, 0, 0, a square, so nothing, 0, a, b plus a, nothing, followed by, now in blue, negative direction, you have 0, 1, a square, nothing, 0, a, c minus b, nothing, and 1, 0, b plus a, nothing. Wow, that's nice. And then because there's only one thing being pop up, and then at last we present in a better notation, giving you b minus a, c minus a, and c minus b, so as the final answer of this factorization.